Okay, we're going to continue with our waves unit. So today we're going to talk about how waves interfere with each other, how they reflect off of different ends, and then what happens when you have the interference and reflection going on at the same time. So I put a completed version of these notes on Canvas, so you might want to print that out ideally, or at least have that pulled up in a split screen with this video and follow along the notes as we go through this. I think that would help you a lot. So first we're going to talk about interference. There's a couple really good websites for simulations on this. I'll put the links down in the description of the video so you can check it out. But here we're going to have two pulses coming at each other. I'll just go ahead and start this. Okay, and you see they're on the same side of equilibrium. Okay, so they're going to get to a point where they're going to hit each other and interfere. Now, one thing about waves is, remember, they're not objects. It's traveling energy. So they can't occupy the same spot at the same time. It's just an energy. And so what's going to happen is they're actually going to go through each other. All right, waves go through each other. You can look at water waves, they'll go through each other. Sound waves, they go through each other. Sound waves, I think, is a good example. When you're talking to somebody and they're talking at the same time, you don't get a reflection back of your voice. No, you still hear the other person coming through. So waves go through each other, and we're going to see that. Now, what we're really worried about is, or we're focused on, is what's going to happen when they do interfere. Okay, when they're completely overlapped. If you look at this blue one has an amplitude of 2, this red one has an amplitude of 2, so you can probably predict what's going to happen. I almost can stop it at the right spot. Oh, come on, can I move this? Okay, so right now they are completely overlapping each other. The yellow is what we're actually going to see. So if this was a string, or, if we were in class, I'd use we've got these really long slinkies, and you can send wave pulses, one from each end. So you don't see the individual pulses when they combine. You're going to see the combination, which is the yellow. Right now, the blue and the red, you're not going to see that. You just see this big amplitude of yellow, which is, look at that, an amplitude of 2. So each of them individually have an amplitude of 4. Each of them individually have an amplitude of 2. Together, they have an amplitude of 4. It's that easy. If we look at a point over here, at this point, the red and the blue each have an amplitude of 1. 1 plus 1 is 2. Okay, so the amplitudes do just add up like that. All right, so we can see it go flying by again. Okay, now what if they're on opposite sides of equilibrium? So that's what's called out of phase. What do you think is going to happen here? Okay, so this one we can say has an amplitude of +2, and this one an amplitude of -2. Well, what's 2 plus a -2? Yeah, 0. Okay, so I didn't mention it, but the last one, when they add together like that, we call that constructive interference. This one is destructive interference. You've got the crest and a trough. They destroy each other. So what you're going to see is just a single straight line, whether it's the string or a slinky or whatever it is. You're going to see that total destructive interference like that. So you're not going to see the red and the blue. All right, now I'm going to stop that. I'm going to do unequal amplitudes. Okay. So now the red has an amplitude of 2, the blue has an amplitude of 1. I'm going to get to a point where they're completely overlapped. Oh, I didn't stop it. I tried. Oh, look at that. Okay, so you've got the red is up 2, the blue is down 1. So you add a +2 and a -1. Your result, the yellow, ends up being a +1. Okay, so adding waves, it really is that easy. You just add the two amplitudes. If one is below equilibrium, you can call that negative, but it all works the same way. We call that wave superposition. So in the first part of the notes, you can see constructive interference and destructive interference. That's really what I just showed you there. So in each of them, each pulse has an amplitude of A, and then in constructive interference, when they overlap, you have 2A. Destructive interference, when they overlap, you have nothing. Okay, so that is interference. All right. let's talk about reflection next. Okay, so a different website here. These are awesome simulations, though. You should check them out. They have a lot of different stuff. By the way, when you get to, hold on. Oh, this is the same website. But when you get to this, you're going to have to go to the menu up here, go down to waves, and then that first one I did was what did you addition, and then this one is the reflection and transmission. So you'll have to go through that menu to find them. But anyway, first let's have what's called free end reflection. So free end, imagine a string down here, and then there's a ring at the end of this and a post, and this ring is allowed to slide up and down along that post. So that's what we call free end. It's free to move like that. So let's start this. Okay, and I'm going to stop it. Okay, so when this wave pulse gets to the end here, like I said, that ring is allowed to move up and down. So if we have a pulse above equilibrium right here, when it gets to this ring, it's going to pull that ring up. Okay, and then we should see some energy reflected back. Okay, and notice the reflected wave is upright like that. Okay, none of that energy gets flipped over to below equilibrium. And if we look at right at the moment, well, close, right at the moment, oh, I forgot these buttons. Okay, the reflected energy is lined up with the incident energy. You know, again, we have that superposition, the addition, in this case, constructive interference of those. Okay, so a free end reflection, the reflected wave is upright. All right. Now let's go to a fixed end reflection. So fixed end, right at this point, it's not allowed to move. It's nailed in place there. So when this wave gets here, it's going to try to pull the string up, but it can't because it's fixed there. So what happens is that energy just gets inverted to the other side. So we'll see that here. Okay. So again, it's showing the components here. Let me move this forward. So right here, the red would be the reflected energy, the white would be the incident energy, the yellow is what we're actually going to see. So at this instant, it's going to be flat, and then it keeps going from there. Okay. Again, these are easy demos. If we were in class, we could do these, but I have to resort to simulations. There's also another good video. I'll put a link to that in the homework assignment. You guys should really watch that. Another flipping physics video. That guy is awesome. Okay, so the big thing here is fixed end reflection, the wave or the reflected wave is inverted. Okay, free end, it's upright, fixed end, it's inverted. I have to keep referring to my note sheet, make sure I'm on the right track here. Okay. All right, so I did those two demos in opposite order. First, on the note sheet, I have fixed end and then free end, but I'm sure you'll figure that out. Okay. All right, so next, we've got standing waves. Okay, so standing waves, I'm going to go back to this. All right, so standing waves, definition, a standing wave is a wave that appears to be standing still. Okay, that's really where the name standing wave came from, I would imagine. But what happens is the reflected wave interferes with the incident wave. Okay, and we can see this through, yep, another simulation. So now this is a different website. Okay, another great resource. Again, I'll put this link down in the description. And this, I think the link will take you actually to this simulation, but you can check out the other ones. So anyway, we've got a fixed end. That's all we're really going to deal with in this class. I'm going to start this. Notice I'm not in slow motion. Okay, there's slow motion. We could be here all night. Okay, so I'm not in slow motion. I think I can get this. I'm just going to advance this along a bit. Okay, all right, now I'm going to go back to animation. So we have the wave coming in, all right, and the red is the energy of the wave, and it's going to get to the fixed end, and we just learned that at a fixed end, that reflected energy will get inverted. It'll flip over, Okay, and again, you know, there's another demo I do in class with this. I'll have two people, usually I'm one of them, with a pretty long spring in between us, and I'll just start shaking the spring and creating the standing wave. The thing is, you see a standing wave in real life like that, it happens, it forms so quickly, you don't really understand what's going on. This simulation really shows us what's going on. So I'm going to continue this, and when we get to this fixed end, we know that that reflected energy is going to be inverted. All right, so I'm actually, oh, we can do this. Okay. All right, I missed it. Darn it. So anyway, the red is the incident energy. The blue is the reflected energy. We don't see the red and we don't see the blue. We see the combination of these. Okay, so we've got a crest here and a trough here. We've got some destructive interference. If I were to stop it at just the right instant, the black is what we actually see. So if this was a rope, we would just see this black rope. You know, we wouldn't see any of that red or blue. We'd just see the black rope. And at that instant, it would be flat right there. And we can continue this. Okay, that's pretty close. So right now, the incident wave, the red, we've got a trough at this location. The reflected wave is the blue. It's also a trough. We have constructive interference. So look at this. It gets a big amplitude like that. Okay, so that's, it's starting to create that standing wave. All right, but it is just constructive and destructive interference. I'm just going to let this continue, and then we'll see how this wave forms. Okay, the A's and the N's, it's labeling in here. We'll talk about that in a minute. You see that on the note sheet too. Okay, we're getting close to the end. So you see, you know, again, the black is what we're going to see. That is the rope, that is the spring, whatever it is that's we're using here. But you see, it doesn't look like it's moving back and forth. It's just kind of bouncing up and down like that. That's a standing wave. Okay, the red and the blue are the energies that are moving. Again, the red is the incident energy, the blue is the reflected energy, and then you've got constructive and destructive interference like that. Okay. All right. I didn't time this very well. I'm going to run out of my time limit on this video. So I'm going to stop it right here, and then I'm going to create a new video just to finish up these notes, just maybe 5 minutes more, and that's it. So go ahead and go on to the second video here.